with the subscript. So if, for example, in water, I can write 2H plus O, 1 O, because there are 2 hydrogens and 1 oxygen, isn't it?
Yes. Yeah.
If I replace the symbol with the charge of that element, and if the molecule was neutral, then the sum should be equal to 0. So in a neutral molecule, the algebraic sum should be equal to 0. Are we together? Yeah. Yes. So that is why, in this case, hydrogen, we are giving it plus 1. 2 times plus 1 is plus 2, isn't it? Yes.
Yes.
Plus oxygen, we are giving it negative 2, and it is 1. Plus 1 times negative 2. So you find that the sum is 0, and that is why the molecule is 0, right?
Yes. Yes. Yes.
If you have a radical that is charged, then the algebraic sum of the element times their subscript should be the charge on that radical. That is the point I want to emphasize. For example, now here, this is not a good example, but let's first of all, let's use this one now to emphasize what I have already said. In Na2S4O6, then we can say it is 2Na, isn't it? Yes.
Yes.
Plus 4S.
S plus 6O.
6O. Yeah. Now, what we don't know, the oxidation state we don't know is that of sulfur. Because for sodium, we know that it has to be plus 1, isn't it?
Yes.
And oxygen, we have already said it has to be negative.
Negative 2.
2.
But the sum, because it is a neutral molecule, should be equal to 0, isn't it?
Yes.
So it should be plus, so 2 times plus 1 is plus 2, isn't it?
Yes.
Yes.
Plus 6 times negative 2 is?
Negative
12.
Negative 12 plus 2 is negative 10, isn't it?
Yes.
Yes.
So negative 10 plus 4 sulfur is equals to 0, right?
Yes.
Yes.
So what is the oxidation state of sulfur in sodium thiosulfate? Because that is thiosulfate. It means that S, the charge in 4 times sulfur is equals to 10. So what is S?
Last 10.
10 over 4 is 2.5. Yeah. So
Yes.
in thiosulfate, it means that there is, what happens is that sulfur, some of the sulfur atoms are in plus 3, the others are in plus 2 equally, meaning that then the net, the average is 2.5. Of course, it cannot be 2.5. It means that one is plus 3, the other one is plus 2, right?
Yes. Yes.
So that now the average becomes 2.5. Are you together?
Yes.
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 Now let me ask you, in carbonate, what is the charge in carbonate?
Negative. Positive 2.
It is negative 2, isn't it? In carbonate, the charge is negative 2, right? And carbonate is written as CO3, isn't it?
Yes.
CO3 negative 2. So meaning 1 carbon and 3 oxygen, the net is equals to negative 2. So if we are to write an algebraic equation, it will be 1C, right? Plus 3O is equals to negative
2.
2. So, but we know the charge it is what?
Negative 2.
Negative 2. So 3 times negative 2?
Negative 6.
Negative 6. Plus C is equals to -2. So what is C? If you now
-4.
solve that equation, it is
Positive
plus
4.
+4.
positive
Yeah.
4. So in carbonate, carbon is bearing a +4 oxidation state, right? Which is a normal oxidation state for carbon, right?
Yes.
Yes.
So then suppose I ask you, what is the oxidation state of sulfur in SO4 2 negative? So can you calculate? What is the oxidation state of sulfur in SO4 2 negative? That is in sulfur.
+6.
SO4 2 negative.
Others.
+6.
Positive
+6.
It is?
plus 6.
Positive 6.
It is positive 6 because 4 times -2 is
Positive
-8
6.
plus S, which is 1S, is equals to -2. So it means that S is equals to negative, no, no,
plus 8.
of course,
2 minus 8.
8 plus -2, which is +6. Yeah, isn't it?
Yes.
Now, usually when we are giving the oxidation state of an element, we designate it in Arabic numbers, the atom. For example, if we say we want to say sulfur is +6, then we'd say sulfur 6, Roman, V and I, isn't it?
Oh, yes.
So here are some examples. So in NH4 plus, the equation should be 1N plus 4H is equals to +1, isn't it?
Yes.
We give what? So we give hydrogen what?
+1.
+1. And so what would be the oxidation state of nitrogen?
Neutral.
-3.
What?
Minus.
It must be -3 so that the equation is balanced, isn't it? So anyway, they are given there. And you can see how you calculate. If NO2 negative, oxygen.
I have a question, sir.
Yes.
What of in the cases of fractional?
Of?
Like the case that you had found in the thiosulfate, the case of sulfur having a 2.5.
That is what I'm saying. There are 4 sulfur atoms, isn't it?
Yeah.
So when you say 2.5, it means it is the average oxidation state. Sulfur can have multiple oxidation state, isn't it? And that is what I was saying. In that case, and it is, you see, S4O6. What that means is that each 2 sulfur atoms, one sulfur out of the 4 sulfur atoms, 2 of them are in a +3 state, the other 2 are in a +2 state, so that you get an average of 2.5. That is what I was trying to tell you. So it's only that now we are giving, the average oxidation state, right? Are we together?
Yes. Yes.
Because, of course, in reality, you can only lose a full electron or gain a full electron. You can never gain a half, isn't it?
Yes.
I have a question.
Yes. I'm listening.
The question is, what criteria will you use to determine that Some of there will be three. Some of them will be 3 and others will be 2, so that you may get the average of 2.5.
No, you can only calculate the average. Now, that one is another chemistry altogether. So what you can do on yourself is to say that an average oxidation state of 2.5.
All right, thanks.
Yeah. So we are given several oxidation states. So probably let us go to NO3 negative in nitrate. So what is the equation? It is 1N plus 3O is equals to
-1.
negative 1. So each oxygen, as I said, you put into bracket for a oxygen, you put -2. So it becomes 1N plus -6 is equals to -1, isn't it?
Yes.
Correct? -1, sorry.
Yes.
-1. So if you add +6 on either side, so on one side you get N is equals to -1 plus 6, which is positive 5. So in that case, in NO3, nitrogen is +5. Are you together?
Yes.
Yes.
So basically, that is how you calculate oxidation numbers or oxidation states of element. So if you are given either a neutral molecule or a charged radical, by considering what are considered to be constant oxidation states, mostly in hydrogen and oxygen, then you can be able to calculate the oxidation states of those elements that exhibit multiple oxidation states, because you can never know the oxidation state of sulfur unless you calculate it, because it exhibits multiple oxidation states. You can never be sure about the oxidation state of, say, manganese unless you calculate its true oxidation state, depending on the compound or radical it is in, right?
Yes.
So are we understood? Yeah.
Yes.
So these notes
Daktari.
are already in your in your e-learning site, other discussions, so you can go and look at this. So we should be on Wednesday, we'll be able to complete on redox and then start on something else in the evening. Are we together?
Yes.
Wednesday we'll have a class in organic chemistry at what time?
Inorganic at 8 in the morning, 8 to around 9:30, and then from this hour, the ordinary hour.
Is this the first class in the morning, or you've been having them?
Yes?
No.
You're asking whether it is the first class, but today, even if it was the first class, today would have been the first. No, we've been having them. You are saying the one for 8. Yeah, it will be the first class for 8. It is, that one is a special class. I'll just pin it.
Okay.
On which day? Thursday or Wednesday?
Wednesday. Thursday, sorry, not Wednesday. Thursday, 8.
So Thursday we'll be having 2 classes.
Yeah.
Can you make it in the evening? Can you make it in the evening like we made that one for organic chemistry?
You prefer 4?
Yeah.
Then I'll make it 4. Then you can tell the others it will be at 4, and then I'll fix it at 4. 4 to 5:30, and then 6:30 to 8.
Okay.
Excuse me.
Yes, go ahead.
Is it possible that we can have an extra class for this unit?
That is what we are talking about. that on Wednesday we shall have a class from 4 to 5:30. Another
On
one from
Thursday.
On
for
Thursday,
that-
not Wednesday.
Thursday, sorry, not that, not
Thursday.
Thursday. Yeah. On Thursday we shall have a class at 4 to 5:30 and from 6:30 to 8.
6:30, which unit?
The same. So we shall have
The same
we shall
unit.
divide our classes into 2. So that so one will be like a remedial class or a makeup. Let me put it that way. Together?
Will you find the link in the calendar?
Excuse me.
Okay.
Yeah, I'll link to the calendar. I'll link to the
Sorry.
calendar. And I also said the link. So I'll link just the same way I've linked this one. I'll just link for that particular day.
Okay.
Yeah. So have a good night.
Thank you.
Excuse me.
Yes. Go ahead.
Excuse me. I'm
Yes.
asking,
Yes.
whether you're going to post the second cut.
Yeah, when I do, I'm going to inform.
Okay.
Yeah.
Thank you.
Sir, excuse me, sir.
Yes. Go ahead. I can hear you.
I had technical issues in submitting the cut. I request that you do resubmission for me.
So just
Please, sir.
said your admission number because I cannot said that your admission number.